Hello students, welcome to experiencetutor.com. Today we'll go through IIT Mathematics Complex Number Part 3.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Geometrical representation of a complex number. In the figure, we can see two complex numbers P and Q are represented by Z1 and Z2. Then OR, the diagonal of the parallelogram OPRQ, gives the addition of these two complex numbers. Subtraction. So subtraction of a complex number, subtraction is subtraction can be geometrically represented as shown in the figure. If Z1 and Z2 are the two complex number, then parallelogram OPSQ dash S represents the complex number Z1 minus Z2, or OS represents the complex number Z1 minus Z2. So if Z1 minus Z2 can be represented as x1 minus x2 plus I y1 minus y2. In Cartesian form. In polar form, we can write z1 minus z2 as r1 cos r1 cos theta 1 minus r2 cos theta 2 plus I r1 sin theta 1 minus r2 sin theta 2. Multiplication of two complex number can be represented as z1 into z2 is equal to x1 x2 x1 x2 minus y1 y2 y1 y2 plus I x1 y2 plus x2 y1. In polar form, we can write it as z1 z2 is equal to r1 r2 r1 r2 cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2 is equal to r1 r2 r2 theta to the power I theta 1 plus theta 2 theta 1 plus theta 2. It follows all the properties of multiplication. Closure law. According to closure law, if two complex number are multiplied, the result is also a complex number. Commutative law, z1 z2 is equal to z2 z1. Associative law, z1 z2 z3 is equal to z1 bracket z2 z3. Multiplicative identity. For any complex number x plus I y, there exists a complex number 1 plus I 0 such that x plus I y multiplied by 1 plus I 0 is equal to x plus I y. 1 plus I 0 is called multiplicative identity. Multiplicative inverse, for every non-zero complex number z is equal to x plus I y, x is not equal to 0, y is not equal to 0, we have a complex number x minus I y upon x square plus y square such that x plus I y, x minus I y upon x square plus y square is equal to 1 plus I 0 is equal to 1. X minus iy upon x square plus y square is equal to x upon x square plus y square minus iy upon x square plus y square is called multiplicative inverse of x plus iy. Distributive law, for three complex number z1, z2, z3, z1 bracket z2 plus z3 is equal to z1, z2 plus z2, z1, z3. In this case, so we can see it follows all the multiplication laws. Now let us solve few of the problems. The question is, if z1 is equal to 2 plus 3i and z2 is equal to minus 1 plus 2i, then find first z1 plus z2, second z1 minus z2, third z1 multiplied by z2, and fourth z1 divided by z2. So let us start with the first one. Z1 plus Z2 is equal to 2 plus 3i plus 3i plus minus 1 plus 2i is equal to 2 minus 1 plus I 3 plus 2 is equal to 1 plus 5i. The next question, z1 minus z2. So put the values of z1 and z2. 2 plus 3i minus 1 plus 2i is equal to 2 plus 1 plus 3 minus 2 I is equal to 3 plus I. Third number question, Z1 multiplied by Z2 is equal to 2 plus 3I multiplication sign minus 1 plus 2I, which is equal to minus 2 minus 6 plus 4 minus 3 I. This will give minus 8 plus I, and this is the answer. Fourth sum, Z1 divided by Z2, which is equal to 2 plus 3I upon minus 1 plus 2I is equal to 2 plus 3I bracket 1 upon 1 minus 1 plus 2I is equal to 2 plus 3I 1 upon minus 1 plus 2I multiply and divide by minus 1 plus 2I minus 1 minus 2I minus 1 minus 2I. So we'll get it something like this: 2 plus 3I 2 plus 3I multiply minus 1 minus 2I upon minus 1 whole square minus 2I whole square. We can again write as 1 upon 5. After solving the denominator we get 5, and bracket minus 2 plus 6 plus minus 4 minus 3i is equal to 1 by 5. 4 minus 7i. Now we have a question. If z1 is equal to 3 minus 2i, z2 is equal to 2 minus I, z3 is equal to 2 plus 5i, find z1 plus z2 minus 2 z3. So we'll put the values of z1 plus z2 minus 2 z3 is equal to 3 minus 2i plus 2 minus I minus 2 z3 is 2 plus 5i, which is equal to 3 minus 2i plus 2 minus I minus 4 4 plus 10i. Upon solving, three plus 2 minus 4 plus minus 2 minus 1 plus 10 minus 2 minus 1 minus 10 I, which is equal to 1 minus 13 I. Here we have a question. If 7 if z is equal to 4 plus 7I be a complex number, then find additive inverse, second multiplicative inverse. So additive inverse will be inverse will be minus 4 minus 7I. It will be minus 4 minus 7I. The multiplicative inverse will be multiplicative inverse will be 1 upon 4 plus 7I so we can write multiply by 4 minus 7I 4 minus 7I which is equal to 4 minus 7I upon 4 square minus 7I का square which is equal to 4 minus 7I upon 16 plus 49. Which is equal to 66 4 minus 7I upon 66. And 49 plus 65, it will be 65. Therefore, we can write it as 4 by 65 7 by 65 I. Now we have a question where we have to express in a plus ib form. So let us do the first one. Half plus 3I whole square. So if we put the formula here, a plus b whole square, then we will get 1 by 2 square plus 3I square plus 2 into half into 3i is equal to 1 by 4 minus 9 or plus 9 I square plus 3i is equal to minus 35 upon 4 plus 3i. The next question is two plus 3i bracket 2 minus 3i, which is equal to so 4 minus 9i square is equal to 0 I, 13 plus 0 I. Now we have a question. Express the following in a plus ib form. First, 1 by 4 plus 4i to the power q. Second, 1 by 2i to the power minus 3. So let us solve the first one. A 1 by 4 plus 4i to the power minus 3. We can write it as 1 by 4 whole cube plus 3 1 by 4 4i 4i whole square plus 3 1 by 4 whole square 4i into 4i plus 4i का whole cube. So we can write it as 1 upon 64 plus 12 I square plus 3 by 4 3 by 4 I minus 64 I. This will be plus 64i square. So let us see again. 1 upon 64 plus 12i plus 3i upon 4 I 3i upon 4 plus 64 IQ. IQ, which is equal to 1 upon 64 minus 12 plus 3 by 4 I 3 by 4 I minus 64 I. Here we can get the chemistry numerical. No, so on solving it we can get 767 upon 64 plus minus 253 upon 4 I. The second question, let us solve the second one. The second question is one one minus 2 I to the power minus 3. So we can write it as 1 by 1 minus 2i whole cube. To the power minus 3. So now we can write 1 upon 1 minus 2i whole cube, which can be solved as 1 cube minus 3 2 plus 3 1 and minus 2 square minus 2i cube minus 2i cube. So on solving we can get it 1 minus 6i 1 minus 6i minus 12, 1 minus 6i, then we can write it as plus 12 minus 12 plus 8i minus 12 plus 8i plus 8i is equal to we can write it as 1 upon minus 11 plus 2i. We multiply and divide by 1 upon minus, so it will be 1 upon minus 12, then minus 11 minus 2i upon minus 11 minus 2i, which is again equal to 1 upon minus 11 plus 12 2i. So we can write it as minus 11 minus 11 minus 2i minus 11 का whole square minus minus 2 का whole square. Now upon solving we can get the value as minus 11 minus 2i upon 125, which is equal to 11 upon 125 minus 2 under bracket 125 I.
If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.